Sometimes when you leave Google Colab inactive for so long, your session will be disconnected. So sometimes you will have to rerun or load your data frame that you have loaded. So in our case, I believe that our runtime was disconnected. So let's load our data again. As you could see that it wasn't able to read the pd.readcsv function since we haven't um, loaded the or run the libraries that you're trying to use. In our case, we're trying to use pandas as PD. So that's why it's important to rerun your code uh, if your runtime has disconnected. You can check the runtime here in the status. So we have done from all of these. Now let's run the correlation matrix since we are gonna use it now. So now after we have built this correlation matrix and we identify our target variable, we saw the distribution and we've checked our data for the missing values. We made some visualization to distribute the heart disease frequency by gender, and then we cross-tabbed uh, the heart disease by age and max heart rate. So now let's start with a histogram. So we'll plot a histogram of the age column from the dataset, and this histogram will display the distribution of ages of the dataset. The histogram is useful, to visually understand how the data is distributed. It shows how frequently each age value or range of the ages that we have in our data set. So let's start by typing the code. It's not that complicated. So we'll use our data frame here. Age dot plot, and we'll specify his. Okay, and that will help us to show us the age distribution within our data set. So let's call that plt.show. As you could see that our data were distributed, our age data were distributed. Let's put some comments here. Data set. As you could see that our histogram is made up of pins or bars, and that show the frequency of age values within different ranges. You can read that in a shape of distribution. You can identify whether an age distribution is normal. As you could see in our cases, like we have uh, more patient between the 50s and 60 and 65. Here are the main um, distribution that we could see from our histogram. We can also understand whether our data, in case if there are more younger individual or older individual within the data set. In our case, that you could see that the older individuals are more than the younger individual. So that's all for showing the histogram, how we can use the histogram to show our age distribution within our data set. If you recall that one of our highly correlated features with the heart disease were the chest pain, and the chest pain had different levels or different types. We have, if you recall, when we were building our data dictionary here. Okay, so we have the chest pain type here. We have typical angina, and then we have non-angina pain. Then we have atypical angina, and the last one is the asymptomatic type. So let's try to do some crosstab function here to summarize the distribution of the chest pain types or level relative to whether individuals have heart disease or not. And that will provide us like a starting point for further analysis and may guide us further for the future selection process to help us building our predictive model. So as you could see that we have here, each of these values are representing a type or level. So let's now do the crosstab for chest pain types. We'll start by defining PD with crosstab. And we'll take our data frame. We'll use the chest pain, and then data frame target. As you mentioned, that this function is gonna create uh, to examine the relationship between chest pain levels or types with individuals has heart disease. Let's run this code. Okay, so as you could see that we have our target variable here, which represents 0 where patient has no heart disease, and here is 1 where the patient who has a heart